Good afternoon, everyone, and welcome to today's Ed Talk and AWS Discovery Day on Agentic AI Foundations. Thank you all for making time to join us from across organization, technology teams, and globe. Today, AI is moving far beyond simple prompts and chatbots. Organizations worldwide are exploring how autonomous AI agents can reason, plan, make decisions, and execute complex tasks with minimal human intervention. This session has been designed to help you understand that evolution from LLMs to agentic AI systems and what it means for engineers, architects, and cloud professionals and business leaders. We also have a special edition today. Beyond the AWS Discovery Day curriculum, you will get to see production AI agents in action, helping bridge the gap between theory and real world implementations. Before we begin, a quick note. We have a giveaway for the participants attending today's session. Stay tuned throughout the webinar and don't miss the details. Will be shared later. Now, it's my pleasure to introduce today's speaker, Naveen Shahi. Naveen has been an AWS Authorized Instructor, Cloud Architect, Consultant, Gen AI expert for over 24 years. His experience in cloud architecture and consulting and technology enterprise enablement have been recommendable. An AIT alumnus, he has trained professionals across Fortune 500 organizations and help enterprises accelerate their cloud and AI transformation journeys. His expertise spans AWS cloud modernization, automation, security, DevOps, and emerging AI technologies. We are excited to have him guide us today with AWS Discovery Day on Agentic AI Foundations. Over to you, Naveen.
Thank you, Ashutosh, for introduction and welcome you all to the Discovery Day, where we are going to explore the landscape of current AI uh, and how it is impacting the industries, how it is making it better and more efficient to deliver maximum customer value. Uh, Before we get started, I'll just like to have a ping test. Um Just in the chat, just type in the city from where you are attending this
Sorry,
and
Naveen.
your.
Sorry, Naveen. Naveen, we can't see you. Your video is not working, maybe.
Uh, okay, all right.
Great.
Am
It's
I
nice to see you.
all right?
Yeah.
All right. Thank you, everyone. All right. So just in the chat, just ping me your current city where you are attending this from and company that you work for. Just to get started, this is my typical ice-breaking process. And just to see the enthusiasm, I just want to make sure that everyone is excited to learn what we are going to see through today. All
People
right,
from
great.
Chennai,
Yeah,
Kolkata,
all right. We
Chennai.
have like New Delhi, Hyderabad. Yeah, pretty much. So great to hear that we are kind of representing all of India and the technology power that we are. Uh, so just in terms of today's agenda, today's 2 hour session. What I have decided is that the first hour we are going to actually look at the landscape so that we are comfortable with the general terminologies, technologies that we are actually going to discuss. And next part, next 1 hour, we are actually going to do a live demo where we are going to incrementally build one of the AI agents. Uh, and we are going to build it incrementally over like three, four, five agents with increasing complexity so that it is easier for us to understand and digest the concepts that we discuss and get to how to deploy those in production environment. So let's get started. Let me share my screen. Um, so
We are seeing multiple slides. We are unable to see one pinned slide.
yeah, actually, just give me a moment. I'm just setting it up. Uh, presentation. All right, give me a thumbs up if you're able to see introduction to agentic AI on AWS. Give me +1 in the chat. Give me a +1 in the chat. All right, great. Thank you. All right, so let's get started. In terms of agenda in this session, we are going to learn the evolution of AI systems, agentic AI essentials, and also AWS solution, these services to actually enable our agentic AI. Uh, just in terms of evolution, I mean, we are all familiar with generative AI. We all use it day in, day out, be it for official purpose or to basically plan our vacations or asking some inputs on our health, right? It's pretty intuitive. It simply follows a set of rules. You give it a prompt and it basically generates a response for you. Then you have generative AI agents. Uh, these are there to achieve a singular goal, but they are kind of work in an autonomous fashion. They can connect to tools, they can get the job done. And then you have fleet of agentic AI systems, which are like fully autonomous multi-agentic systems, kind of a team of agents working together to deliver a project or deliver end goal or results, right? So kind of very closely mimic human logic and reasoning. So I'm a big movie buff. I remember watching Iron Man, and that day I used to think that I wish I had a Jarvis and what I could do with a Jarvis. But you should be careful of what you wish because your wishes always come true, right? So, just in terms of analogy of what we discussed on the previous slide, Jarvis could be like very similar to a generative AI assistant. You just tell me, it creates contents or insights. Uh, Iron Man is more like an AI agent. You basically give Iron Man a mission, but you actually are not specifying the recipe of that mission. So it is Iron Man is going out and trying to figure things out for itself. Optimizing, innovating on the way in terms of the path it has to follow to meet the goals. And then you have Avengers. It's a team of great guys like Iron Man, Hulk, each coming with their own specialty or tools to execute and meet your end goals, right? So this kind of pretty much just summarizes the lay of the land. Uh, it's important that we understand some of the terminologies and how they are related. There are a lot of terms that get thrown around. Uh, this uh, this diagram actually kind of shows the relationship of these terms with each other. So artificial intelligence itself is a large subject in a wide area. Within artificial intelligence, you have a specialized area called machine learning. Within machine learning, you have a specific uh, specialization in terms of deep learning, and deep learning is what you know uh, generative AI is derived from. Okay. Uh, just in terms to how to understanding how actually LLM works, it's not very difficult to think if we just understand how our knowledge actually works or how our brain works, right? So I'm sure that a puppy is to a dog as kitten is to, right? And could you just generate the response over here? What it could actually be? Just type in the chat. A puppy to is to a dog as kitten is to a dash dash dash, right? What could the answer be, right? And exactly, right? So this is exactly how any generative technology would work. I mean, you would be able to predict what the next token or term or word is actually going to be. Uh, how does this actually work? So we through our real world experiences, our brain has been trained with huge amount of data right from our childhood, right? In terms of visual input, in terms of audio input, uh, our brain has basically all these levers, weights that it is basically calibrating all the time that actually helps us generate the next token or the word. Uh, and this is where the first concept of tokenization and encoding actually comes. Uh, Machines do not exactly work like the brains do, right? So we as a human are good with language, words, meanings, semantics, whereas computers are pretty good with numbers, right? So just as an example, on our phone, we actually, if we have to call someone, we essentially are not punching those numbers. We are essentially searching our contacts and making that call. But the machines actually work with IPs, and because they are very good with numbers, right? A puppy is to dog as kitten is to essentially gets encoded as tokens. So I'm not going to go very deep into it, but essentially it's a number that is assigned to these tokens. uh, and later on we'll find out how these actually get related to and how it helps the technologies be generative and smart. Okay. uh, Word embeddings, how are these words represented? So essentially, each word, because of a large amount of data that they have been trained on, you can think of this as a 2D vector space, uh, kind of like the Google map, where related cities and districts and streets are kind of clubbed together, meaning that their vector representation is similar. So, for example, term like king and queen would be placed very close to each other in terms of vector encoding because they both are associated with some sort of a royalty, right? Similarly, the relationship between dog and puppy. So this is the kind of relationship between them, right? Uh, and the way you are able to uh, get to the next token is just by comparing relatively this vector and this vector, you find it similar, and that's why you're able to predict that next token. Okay, so remember this word embedding, right? So essentially, in a very simplistic term, embedding is essentially associating a number. All the words have some sort of number, and those numbers are represented in vectors. There is a vector space of all these tokens. Related tokens are placed relatively closer, and basically that basically helps the machine generate semantic meaning out of it. Okay. All right. And this is exactly what is happening. So, in terms of predicting what the next term is going to be, the cat essentially gets computed with the prediction numbers. These are obviously probabilistic, but probability wise, cat is going to be the next token over here, and that is what helps it select it. Let's talk about large language model. Uh, it works as simple uh, as sending a prompt. Agni, that's correct. Actually, there is tokenization, right? And obviously, yes, there are different algos. So keeping it pretty high level. So just in terms of large language model, we have a prompt. Okay, when did French Revolution take place? Essentially, there is an inference that is going to happen, and large language model is going to generate a response. Okay, uh, and these LLMs are basically pre-trained on massive collection of high quality text. Uh, and each of these texts basically are stored in large data centers. There are these numbers association that happens with this data, and essentially inference is a process where your prompt is input to the large language model. It is essentially tokenized, and then the inference happens, and the large language model is able to respond. Okay. Uh, there are some typical challenges that are associated with LLMs. I mean, LLMs have started being used at the corporations, companies, large organizations for different use cases. Uh, but what we have seen in the field, and this is something that all of us should be aware of it, that yes, LLMs are great, but there are also limitations to it. So as the task complexity increases, or the input size increases, or the output scope increases, uh, the the reliability with the LLMs actually reduces, right? The cost increases and the reliability decreases, and that's why AI agents actually help LLMs act, remember, and reason across multiple steps, which is not very intuitive for LLMs. All of us have worked with LLMs, and um, we basically need to go through multiple prompts, multi-shot prompts to get our responses. We'll take upon some examples, and I think this challenge will be very clear, and how AI agents help us, mitigate some of those challenges. Uh, all right, so this is kind of highlighting what we saw in the previous screen, right? So suppose I work with a real world agent. I want to plan a Dubai trip, right? And I basically need a 5 day itinerary. Uh, Working with LLMs, essentially it is going to suggest you, hey, you have to fly. These are the flight ticket options. You have to book hotels, tourist, leave, local activities, airport pickup, and you can just read through all the things that it actually takes to actually plan for Dubai 5 trip, right? It almost looks like that LLMs basically are just generating the plan, generating itinerary, but actually they are giving me homework, right? Basically, I have to do all these things. I have to, book flight tickets, I have to book hotels, I have to, you know, arrange for local activities. I just have the content. What do I do with that content, right? Uh, and the question is a generative AI actually helping you getting anything done, right? So what AI did well so far, high level strategy generation, marketing content ideas, communication, sales enablement, drafting FAQs, right? This is all good. uh, where it could not help, scheduling and coordination, right? Out of brand alignment, uh, right? Anything where basically you need to execute stuff, it is not able to do as of yet. If we are just talking at the LLM or generative AI level, right? Uh, this is where AI agents come. So these are basically software systems that actually leverage uh, generative AI to reason, plan, and complete tasks on behalf of humans or systems, right? Now, let's say we have an agent, uh, and we ask it which day in the next week is ideal for Mount Fuji hiking. So instead of LLM basically generating some content for you, it is actually going to think. Um, let's check weather forecasting website. So maybe it is going to go and look at some weather site, get some data for Mount Fuji, right? Then it is going to act. It is going to analyze that data. Mostly rainy next week, but sunny and warm next Friday. It is going to evaluate and reflect, and essentially it is figuring out that next Friday is ideal for Mount Fuji hiking, and that's what the response is. Next Friday is ideal since it will be sunny and warm, right? Uh, All right, these are some of my, before we begin with the agents, I mean, these are some of my very popular uh, uh, agents, 007 in particular. And what's the analogy here, right? We are just trying to understand uh, what what makes an agent, right? Uh, Essentially, it is triggered by defined goals or user requests. It analyzes context, data, and environment, generates plan using reasoning tool, executes task services without guidance, replans, delivers. Right? Uh, think of think of Google Map. Right? When we do Google Map, essentially it figures out where we are currently located. We give it our destination, but we are not telling that, hey, basically we have to go here, so take left on this road, take right on this road, keep going straight, right? That's not how Google Map actually works. It is kind of pretty responsive. So it it essentially calculates at that point in time, and it may have multiple options in terms of routes, and it is going to, depending upon your setting, it is going to suggest, a route that is going to be the fastest, right? uh, and time to time it might change. It might uh, it might find out that there is a traffic jam and it is going to reroute. By mistake, you take a wrong turn. It is again going to replan, right, the trip. So this loop continues till you reach your goal, right? And that is the whole part. This is not a fixed workflow, right? It has no fixed recipe. It is dynamic. Another case is, our the flights that we take, right? Essentially, it there's a autopilot, and autopilot is fed with all the data that is required for the travel. Uh, but there is no fixed recipe provided to the autopilot. Autopilot, what it is doing is it is taking all the real-time inputs as it happens. So during the during the flight, your flight will be deviating 1 degree, 2 degree, 1 kilometer, 2 kilometer, like that. But every time in a loop, right, it is making sure that your flight is on the flight path. Okay. If there is a weather forecast that is bad, wind, stuff like that, it is going to take care of it. So these are real agentic systems, right? Uh, Now uh, let's talk about different type of AI agents. So you have typically the workflow agents, which will have multiple step tasks. Your plan will be predetermined, model as flow router. You have autonomous agents, which are basically self-directed. They have expanded expensive tool sets like computer browser. They can actually mimic human action. Then you have hybrid actions that can actually decide what kind of routes to follow. uh, and then you have agentic virtual workers, right? So essentially, in this case, if you look at the direction, essentially you have increasing autonomy and business impact. Okay. Um, so how do autonomous agents actually work? Uh, More often than not, you have a agentic loop. So you have an agent that is actually going in a loop. You have a start, it is fed its goal, and then you also have the end. Essentially, what is happening here is there is a continuous uh, input, reasoning, and action. Okay, till your goal is reached. So this loop is continuously executed till your goals are reached. So, I mean, in terms of inputs, obviously you have text, images, audio, or any other kind of input that you can think of. You have reasoning, which is powered by LLMs. It can have goals, it can have plans, right? Uh, it has chain of thoughts as prompt context. It can create plans, sub plans, and essentially it is going to act on it, right? It is going to replan if something goes wrong. It is going to keep doing that loop till your goals are actually achieved. Okay. There are two major autonomous agent architectures. There is a React architecture and there is a Review architecture. Uh, Reason and action, which is basically kind of simulates think, act, observe, think, act, and observe in a loop. Whereas reasoning without observation is think, plan, act, and finish, right? So think of a chef who is who is making a delicacy, right? And it doesn't have any fixed recipe. So basically, while it is executing the cooking operation, it is also testing for salt, spices. It is making sure if to do the readjustment, right? Think, act, and observe. While reasoning with observation is essentially a chef with a fixed recipe, and with that recipe, it can actually plan and it can come up with task one, task two, task three, execute it, and essentially finish it. Okay, so both of these are like autonomous agent architectures that are quite popular nowadays. Okay. Uh, just in terms of sample architecture on AWS, let's talk about restaurant reservation system, right? So you note that you have a customer that is essentially interacting with a restaurant agent, right? Um, it is essentially looking up for bookings. It can execute a lambda that is going to update and basically get the feeds, and then the restaurant agent can actually look at menus, right? So it has essentially two information source of information. It has menus knowledge base. It also has DynamoDB, and essentially it is using both of these to answer questions from a customer, and also it can also execute the booking itself using the booking action group, right? This is the kind of an autonomous agent flow of the last restaurant booking system. So essentially, you have a request from a user. What can you serve for dinner? Can you make a reservation for four people at 9 p.m.? This essentially leads to a few things that are happening. First of all, it has to check the availability in the dinner menu because it has asked for what do you serve for the dinner. So it has to look for dinner menu, and then it also has to look for reservation options. It essentially figures out the step that needs to be completed. It has to search the knowledge base. It also has to interact with the booking tool, uh, dinner menu, right? And essentially, once this whole flow is completed, the task is finished, and there is a response that actually comes back, right? This is a flavor where multi-agent collaboration. So it's kind of a team. So you can have a supervisor agent. So this is a multi-agent collaboration where you have a supervisor agent that can internally work with multiple agents, more like a team, project team, right? You have project lead and you have team members. They are executing their tasks based on what the input requirement from your customer actually is, right? Uh, We are not going to go very deep into some of this. The broadest choice. Give me a minute. So we are going to actually focus on building AI agents, right? And how we can do it using AWS. So AWS, the service that we actually use is Amazon Bedrock. Uh, and Bedrock agents are again autonomous software systems that can use various, LLMs and foundational models that are available within the Bedrock, fully managed by AWS. Obviously, when you're uh, deploying your agents, you don't have to manage any infrastructure built on Bedrock Foundation, and you can use Bedrock for agents that can actually reason, plan, execute, and learn. Right. Uh, So the core components of Bedrock agents, you have the brain behind the Bedrock agent, which are basically the foundational models. There's a playground in Bedrock with over 100 models that you can play around and fine tune based on what is actually required. It allows you to, you know, play with the various models, look at the cost, look at the token sizes, uh, you can plug and play, compare them with each other, right? This all this fine tuning actually happens when you are really executing a real project, right? Then you have the agent instructions, uh, basically in terms of prompts, role tone limits, templates. You also have action groups, right? Uh, we talked about Bedrock agents and basically the brain behind this is the foundation model that you actually use. Um, what can actually happen is that obviously these LLMs are trained on large amount of data, so it can give you reasonably smart responses based on what you have asked, but it obviously doesn't have knowledge. First of all, uh, these trainings actually go in the cycle. So maybe the LLM that you actually use could be 3 months old, 6 months old, right? So it doesn't have context of the current state of the world. It also doesn't have any information about the knowledge base that you have within your organization. So, for example, it cannot answer questions like what's the leave policy, what are your HR policies, right? Things like that, right? So, uh, we can enhance Bedrock agents with additional knowledge, what we call as knowledge bases, popularly known as actually RAG. We are going to talk about it. So you basically create these island of knowledge bases, and you basically pass the information from that knowledge base to your LLM to make it more informative. It's as simple as you're interacting with it, you upload certain document, and basically you start asking questions of that. That answer is going to be more contextual, right? On the other hand, you have guardrails. So essentially, once you expose your agents to the real world, so real world, everyone doesn't, uh, world is not a fair place, right? So they will try to break your agent. They will try to, inject prompt, do all kind of things, right? So guardrails basically puts control around your agents, what they cannot generate in terms of content. You can block harmful and sensitive content, threat detection, policy controls, right? You have a banking agent. You don't want agent to hallucinate and start giving, investment advices, right? That's not what you want your agents to actually do, right? Uh, so we are going to see all this when we are actually building our agents. So if you're not getting all of this, that's okay. When we start looking and start building agents, many of these things will start tying up. So uh, this is overall flow. We at a very high level, 30,000 feet, we just need to understand how these work. So essentially, you have a user at this end interacting with your Bedrock agent. Bedrock agent essentially, you know, uh, has a prompt, maintains conversation histories, can do actions, instructions, and tasks. It is going with all this. It is going to prompt a Bedrock model, uh, and essentially it is going to go through chain of thoughts. It is going to come up with step one, two, and step n. It is going to execute all those steps, and essentially it is going to return your results back, right? Uh, So agent core, I'm not going to go into a lot of detail, but obviously you need a runtime for the agents that you're going to deploy into a production. So it is kind of agent runtime, but it has a lot of built-in features in terms of providing runtime. It can provide identity, authorization, authentication, simplifying tool discovery, short-term and long-term memory, the context. Obviously, when we are conversating with an agent, it needs to maintain the context of our current conversations, which is basically a short-term memory, but basically a long-term memory is also for your interactions across multiple conversations, right? End-to-end visibility to trace, debug, and monitor, all managed and fully managed browser tool and code integration capabilities. Okay, all right. Um, Essentially, the agent core, it basically any model will have a agent run core, a runtime. It basically has a framework that manages instructions, local tools, and context. But it also has, you know, the tools that it can connect with, right? Agent core browser, gateways, a code interpreter. It can basically it provides your identity, observability, and memory, right? So all these services that a typical agent would need to work autonomously, right? All these things are good. And this is not very specific to AWS itself. I mean, generally any agent has actually needs this kind of an ecosystem to work with. But the advantage with AWS is that you don't have to reinvent this wheel. Basically, you can start configuring and using these. Okay. All right. So we are actually, as part of our building, we are going to actually use strands. It's basically an open source Python SDK for building agents. It supports MCP and agent to agent protocol. It has three components: module, tool, and prompts. So we are going to actually stop here. Just give me a minute. I just need to pull up to here. Any questions so far? Because right now, what we are going to do next is actually start building building an agent interactively. Any questions in terms of theory of what we have covered so far? All right, so we are going to switch the gear over here, and I am going to pull up my browser just to show you around the Bedrock first. Uh, Give me a thumbs up if you're able to see my browser, AWS Management Console. Give me a thumbs up in the chat or plus one in the chat. All right, great. One of the question is, what is Bedrock model? So that's exactly we are going to land. Just give me a minute. Um, like any service in AWS, we can obviously search for Bedrock. Uh, and yes, it says the easiest way to build and scale generative AI applications with foundation models. All right. So I'll spend like few minutes just to walk you around the Bedrock dashboard itself. Uh, so you can see this is the landing page. It essentially has a quick start where you can actually get started with Bedrock and you can make your first API call under 5 minutes, right? A good place to actually get started and learn how to generate text, screens, and stuff like that. You have a model catalog. Um, we are actually going to take a look at it. So let's take a look at model catalog actually, right? So you can see that Bedrock essentially is a marketplace for LLMs, right? You have you have all most popular models in one place. That kind of answers the question. You have, for example, Claude. Let's see what we have from Amazon. From Amazon, you have Nova, multimodal, Sonic. Let's look at we have Anthropic. We have these are all the models that are available for us to play around. So whenever we are building a AI solution, obviously a large language model is going to be at the heart of it. It is going to be actually the brain. Um, and this essentially allows you to play around with various options because one thing we always have to be very sensitive is the cost of implementation, right? So I have seen many customers who actually rush towards towards AI powered solutions. Um, and very quickly they find out that the cost of tokens and to run that business sometimes may not justify the actual business value, right? So there is a large runtime to going to implemented solution. There's a lot of fine tuning, playing around POCs that is going to happen, right? So based on what your requirements are, more often than not are going to play around with lot of models to just make sure and have an idea of how the costing is actually going to be. Okay. For uh, There's a question: any model published by AWS itself? Yes, of course there are. You have from Amazon. You have Nova, Sonic, Multimodal, Sonic, Light, Pro, Titan, right? So these are all the models that are actually available over here for you. There are different generational models over here. All right. So this is where it is. You also have a playground, right? So what you can actually do is you can actually select a model to get started. You can choose any of the models over here, right? I'm going to choose uh, Nova Light, apply, and actually you can uh, I'm not going to like run a prompt. It's quite trivial. We all know it is, but a good thing is you can actually compare. You can do comparisons, right? You can select two models and start, fine tuning your responses, request responses, and just figure out, which one is better. You can also play around with uh, lot of different models. Uh, So there's a question, what should be the logic to choose a specific model? So again, it all depends upon the use case. So suppose you only want a very simple, text prompt, right? Uh, there are models that will be very cheap for that. But if you want audio, multimodal, interpretation, in that case, there are different models for that. They are going to be more expensive. So for example, ChatGPT can interpret image, voice, text, everything, right? But for your specific use case, right, you may not need all these models, right? So why would you actually pay for it? Then token cost is one thing, right? Uh, Obviously, I mean, there are models that are trained on huge amount of data. You may not actually need that level of sophistication, in that case, why should we pay for that if my use case is very trivial? Because at the end of it, you're you're basically prompting it, that generates token, there's a response, that generates token, input token plus output token, total is basically the cost, right? And that's how you are being charged, right? Okay, so this is what we had for playground. So what I'm actually going to do is switch gears over here. I have my, let me just pull out my development environment. Um, Let me just clean some stuff over here. All right, so we are going to build an agent uh, incrementally, and that's why if you can see over here, in fact, let me just close this, close all of these. What we're going to start with is a very simple agent, right? And this agent is simply doing what we all do day in, day out with, LLMs, right? We basically prompt it with a text, um, and we get a response back. But the only difference is that instead of, doing it from mobile or doing it from a browser, right? What we are doing is we are actually utilizing Bedrock API, uh, and we are basically using a model over here. So if this is basically a Python code, I've used Python to build this very minimalistic agent that just takes a prompt and just responds back. Okay. In this case, we are using Boto 3, which is basically a Python SDK for calling AWS APIs. Okay. And we are basically wrapping the client passing Bedrock runtime region. These are all the information that we actually need to pass it. We are also specifying a model ID over here. Uh, you can pass any of the model IDs that we just saw. I mean, each of those LLMs or models have their own unique IDs. So whatever model you want to actually use, you are going to actually provide that model ID. We are going to put a system prompt. What we are trying to simulate is essentially a helpful technical assistant chatbot who can explain concepts clearly and concisely. Our message is what is serverless computing. Uh, what we are going to do is we are going to use Converse API from Bedrock runtime. And in this, we are basically passing model ID, system prompt. We are basically wrapping message into an array of messages instead of just putting a large unstructured conversation chunk. We also have additional parameters that determine the quality and characteristics of the response from the model. So temperature is something that is kind of a scale. So scale a temperature equal to 0 means that you don't want this model to be very creative. It needs to be very specific. But if you want very creative answers and you want to give some freedom in terms of creative liberties, you basically are going to do 1.0, right? You also control the maximum amount of tokens to be returned from the model. This is very important because this is basically, dollars for you, right? Uh, you're basically going to get the response which are actually parsing, and we're just printing it out. So not a very sophisticated or a complicated agent. It is kept simple for a reason, and we'll understand subsequently. Okay, and we are just logging that. Okay, and at the end of it, we are just executing this converse. Okay, so we are going to have some sort of conversation. So just a note that This entire code base that I'm using for demo over here actually is available in Git. So I'll share the Git repo for it. So you yourself can actually play around with it. Okay. Uh, just in terms of executing this, we see over here that we are actually importing Boto 3. So this is the package that you need to actually install. Um, let me just take a look at my notepad over here. So these are the links that I'm going to share, but obviously you can install it using pip install Boto 3, right? There are some additional things that we need to install, but we'll talk about it as we go. Uh, now let's go ahead and actually execute it, right? So I'm under sample Amazon Bedrock for beginners here. So I need to just cd into bed Bedrock examples, and I'm going to execute Python uh, converse, right? Let me also maximize uh, the window over here. All right, so let's see what happens. All right, so we can see over here, everything has been printed out. So essentially, system prompt user message is what we printed out. So what is the serverless computing? And obviously, it has responded back um, over here. Uh, and just in terms of token usage, I've also taken advantage of the API to get the token usage. And over here, you can see that input tokens are 20, output tokens are 200, total tokens are 220, and you will be charged, by the Bedrock by your token usage, which is basically both input plus output tokens. Okay. Um, is there an option not to have a token threshold in case we are in a prod environment? Yeah, so obviously, the parameters that we send obviously control your tokens. When should we use single agents versus multi-agent architecture? And I'm going to table some of these questions for end of the session, but good questions nevertheless. All right. Now, this is a very simple agent, if you can call an agent, okay? What happens is that this is a single shot prompt uh, agent, right? There is no interaction over here. But suppose you want to do multi-shot. What we can do is let's actually take a look at the next generation or next iteration of the same agent. Okay, um, we are going to take a look at multi-turn. Okay, so again, this is like a version 2 of the Converse API that we just talked about it. Um, things remain same mostly, but now we have a conversation history over here. And what we are going to do is we are going to pass the user messages into this, and we are going to build the conversation history, right? And if you look at the parameters now, we are actually passing model ID system prompt, same as the previous iteration. Only thing we have added more now is the messages, which is basically the conversation history itself. And we are going to do a three-step, short process. So this is all turn one. Turn one asks for a recipe suggestion, okay, and the messages suggest a quick dinner recipe with chicken, right? For example, some response is going to come back. We are going to add it to conversation history. Then there's a turn two, right? So since we are passing the conversation history, uh, can you make it vegetarian instead? Right? Now it is going to look at the initial prompt. It is going to look at my conversation history and then it is you're going to use both of these, right, to make it, a vegetarian instead, right? And again, this is part of your conversation history, and basically now it is, prompted with additional information, right? And then again, the response is captured, and then there is turn three, right? Ask for cooking time, right? How long will this take to prepare, right? So these are like multi-shot conversational communication that you actually do while maintaining the previous conversations, right? So this is now an additional enhancement on top of what we have done as part of iteration one. Okay. Now let's go ahead and actually execute this. Um, let's clear and let's say Python multi-ton. Let's see what we get this time. All right, so it has returned back. Um, so turn one, so just a quick dinner recipe with chicken, right? It basically is sending all the ingredients, instructions, and also remember that this time we also had reduced the token limits over here, right? So for each of these, chat, we are basically, setting max token as 200, and that's why you see pretty precise. If you ask the same question on, some of the popular LLMs, you'd see, a lot more tokens being returned, right? Uh, this is what the fine tuning is all about. You basically want to get to a limit which basically works for your business requirement, right? So I think where some of the companies have burned their fingers is not taking control of their overall token size and cost. Okay. Uh, Now get back to the response and let's analyze this response. Okay. Uh, Now turn two, we are asking how can you make it vegetarian instead, right? Again, there is a response back. It has basically taken turn two over here. Can you make it vegetarian instead? So it has basically taken all of this conversation into the context, and then basically it based on this, it is suggesting an alternative recipe, right? Minus the chicken. Okay. Now the third one is, how long will this take to prepare? Essentially, it has taken both the previous conversations. Based on that, it has generated a response. It says that, approximately 10 to 15 minutes, right? Again, input tokens, output tokens, uh, and rest, you can actually guess where I'm going, right? Uh, Now, let's just give me a minute, actually. I just before I go to the next one, I want to quickly uh, cover the tools part of it, right? So far, our agents have been kind of, not very consequential, right? Because we have not added any tooling so far, right? So it is still working as like a generative AI models that we know so well, right? So what happens is that uh, for agents, you can actually these models can actually work with tools, right? These tools could be APIs or actions or a data. So essentially, if you talk about LLMs being your brain, right? These APIs, action, and data are going to be your hands with which you can actually take action, do stuff, right? Uh, and there are various tools that are actually available for you to use. Some of the examples could be, your agent might need to, get stock rates. It can get to weather. It can go. It can look at. It may need to send emails, right? So there are different tools that it needs to actually work with that will actually allow the agent to get the work done. Okay. All right. So this is like a overall flow of how we actually do it. Specifically, you create a tool. Um, you essentially inform model of the tool such that it has available. You send prompts to the model. Uh, Model will decide in the combination, and it could be multiple of tools, right? So essentially, it could be tool one, tool two, tool three, and I'm just basically abstracting all these capabilities that you can actually add to your agents. So T1, T2, T3, T4, right? But based on the prompt, the model is actually going to decide if and any of these tools that the model actually needs to use. uh, Model will specify the tool and the argument. It is going to run the tool. It is going to the tool is going to send back the result to the model. Model is actually going to take that result, combine it with additional inputs that it has, and is going to generate response based on that, right? And it is going to keep going into the loop actually, okay, till it achieves its objectives. So hope this flow is actually clear in terms of tooling, because the next agent that we are going to actually build is going to use this concept of tools. um, all right, so let's actually go back to the code now. So the third iteration of this agent, so remember we started with a very simple agent with simple single shot prompt. We basically enhance that agent for multi-shot prompting. Now we are actually going to enhance this agent to start using external tools. Okay. Uh, so what is going to happen over here is that instead of you know uh, going to and connecting to some external system, what I have defined is a tool within my client, which is essentially to get weather report based on location. And right now, I've just like faked a weather data for the demo. It could also be a REST API or whatever it is, right? But right now, I'm just kind of faking a weather data, and this is essentially going to return you the weather data, right? Uh, Step two, we are going to describe this additional capability or function as tools for the model. Okay, so this model basically this basically describes what the tool does, what input it expects. Okay, kind of input schema. It's essentially like passing a documentation to a developer so that he or she understands what this function actually does, right? So just in terms of a tool config, what we have defined is a tool named get weather. We have a brief description of this tool. We also have input schema in terms of what parameters and the schema and the structure is expected by this tool. Okay. So this is basically encapsulated as part of tool config. Now, remember that we can specify an array of tools here. I've just specified one tool over here, but remember there's an array, right? So you can specify an array of tools like this. But to keep it simple, I've just defined like one tool. Okay. Uh, Step three. we actually map the tool to actual Python function itself, right? So you could actually map it to Python functions or Excel API, stock ticker, call to a database, APIs, right? Things like that, right? So I'm kind of generically putting it as a tool over here, okay? Uh, then what we do is we actually define the run tool. Uh, and as part of the tool demo where the crux of the code actually exists, what we do over here uh, is all the things that we have been doing previously, right? So this is by now, I think you should all be very comfortable with this. I also have the messages, right? Uh, now the Bedrock Converse API that we have been using previously, so far we have been passing model ID, messages, and inference config. Now we are also passing tool config, okay, which encapsulates the tool that are available for this agent to actually use, okay. Uh, and essentially, what I'm capturing is the stop reason. So the agent might stop processing if it needs to use a tool. This is what actually I'm exactly capturing. And then it is going to use that tool. It is going to pass these parameters. Essentially, I'm going to run that tool. It is going to capture the response from there, right? And then finally, I'm going to capture the response. So one thing is, it is very difficult for us. It may not be very easy for some of you to actually follow along the code, but just follow the logic, okay? And then once we see it running one time, I think and flow will be kind of little clearer, okay? Control J. Let's go ahead and actually execute this. If I can get my cursor back clear. Hmm, clear. All right. So let's execute this agent with a weather tool. Um, Python tool use. So user is prompting what's the weather like in Seattle right now. So step one is sending message to model with tool definitions. Model responded with stop reason. So it actually figured out, because my prompt is what's the weather like in Seattle right now, it figures out that in set of tools that I have provided, it actually needs to use the weather tool. Model wants to call get weather with argument location Seattle, right? So it has formulated the argument from this prompt, right? I've asked the weather in Seattle, right? So it is basically going to call this tool with the expected argument that is actually defined in tool config. Then basically the function returned from the tool itself is actually this. This is the response from the tool. This is like developer friendly, readable, but you understand that step four, sending tool result back to the model, and the assistant, right, goes into a thinking mode, right? And what is it thinking? I have the weather information for Seattle, also known as this. Step three, I will now present this information to the user, right? And then basically based on this JSON data that it has received, right, it is generating a user-friendly message. The current weather in Seattle is partly cloudy with a temperature of 58 degrees Fahrenheit. Humidity, wind is blowing at 8 miles per hour. So this is a case and scenario where actually it went, fetched the data from a tool and got your results back. Okay. Any questions so far? And when I talk about tools, it could be any tool. So, for example, if I wanted to send an email, think of tools. I want to get a stock exchange, think of tools, right? I want to get information from within my knowledge base, think of tools, right? Booking tickets, think of tools. Looking for travel agents, think of tools, right? So you're guessing it right. I mean, it's all about tooling, adding more and more capabilities, right, to your agent. So agent as such itself is not it. The brain LLM also is not it. It's the tooling set that you use, the hands that can actually get the job done. Okay. Any questions? Sudarshan, you have a raised hand. Any question? You have a question? All right, let's proceed. Uh, Clear. All right, now we have gone through three layers of evolution, right? So we started with single shot prompt, we did multi-step prompt, then we basically added a tool. Now we are going to add another layer of intelligence on top of this agent. Um, Remember that whenever we are building an agent and we are using a underlying model uh, to facilitate that, these are obviously trained on large amount of data, but these cannot answer very specific questions that I may have with respect to my organization, my project. They are not actually trained on that data, right? Uh, for that, we need to augment um, the knowledge that uh, the model has. We call it actually a RAG. Um, RAG is essentially a retrieval augmented generation. So what you can actually do is the way it works is that you have agent. Um, and agent basically you have a user over here who is asking some very specific questions based on data that you have within your organization. Uh, what you can do is actually you can implement uh, RAG, which is basically a vector database where you store, where you create your knowledge base. So you can actually add all your project documents, your HR policies, and anything that is interesting. So we are talking about a bot that can actually answer questions within, say, HR department, or things like that, right? So it needs a specific knowledge base. You need to build this knowledge base, and once you have this knowledge base, then agent can actually query this knowledge base. Uh, and get certain results back, and it can pass it to a model or LLM. Um, so essentially, this is the agent user. Um, you have your knowledge base, KB. Uh, essentially, you have a prompt from essentially you have a prompt from your user prompt. You also have tidbits of knowledge from your knowledge base, the relevant documents or the tokens of those documents, and they basically are all sent as a package to the LLM to give you a contextual information, right? And this is what it is basically: retrieval from knowledge base, augment that knowledge, and include any data in the prompt, and then model uses the information from your knowledge base, and model generates a grounded output that is contextual to what the user actually needs, right? So Agnit, I mean, in this case, I'm using Boto, which is a Python library, right? But I'm basically using Python because I'm using all these as a components to build it incrementally one by one. In real world, you would actually use some sort of agentic SDK like Strands, LangChain, and things like that. It all depends upon what technology you are using, but its function is just a simulation of an API call. API could be anything. Okay. All right. The way this is like a more detailed of what we have just discussed in terms of RAG. Um, so essentially, um, you have basically whenever you create uh, your knowledge base, you are essentially uploading documents of based on those documents. Again, machine knows number better, so it creates embeddings based on those documents. And then it is basically stored in something called a vector database. Um, in this case, when user queries, relevant data is actually returned to the uh, LLM in terms of prompt, query, and the relevant data from your knowledge base. And then basically all of this is used to generate a response back. Okay. So this is what uh, our next evolution of agent would actually uh, look like. So let's take a look at the next piece of agent. So next piece of agent is essentially going to use the knowledge base. Um, and before we actually do that, uh, the knowledge base we are going to create is very simple. Um, let's assume we have a university campus. We are basically developing a campus bot that is going to answer questions from students. Uh, questions could be around academic calendar, right? Could be academic calendar, could be financial aid, the admission process, housing, dining services, registration process, library details, right? So I've just kind of created these text files that kind of represents my knowledge base, based on which this auto response system or bot is going to actually use this knowledge base to formulate the commonly asked questions from the students. Okay. But before we actually do it, we actually need to create this knowledge base, right? So what we are going to do is, um, let us go back to uh, the management console. What I'm going to do is I'm going to actually create a S3 bucket because uh, knowledge base actually needs a source, right? So source could be your S3 bucket, it could be your database, it could be web. We are going to actually see these things. There are different kind of data sources that knowledge base can support. So the story actually starts from here. Okay, we we actually have knowledge, uh, not knowledge base. Uh, just a minute. Um, just give me a minute. Let me just see where I am. I'm in region North Virginia, right? Um, okay, just a minute. Let me just look at where these documents are actually there. Um, Just a minute. Um, yeah, this is fine. So yeah, sorry. Just organizing a little bit. Um, all right. Let's go back to the console. All right. So let's look at knowledge base. Bedrock. I want to open it in a different window. So the story of building up your knowledge base actually starts from a place over here. This is where you actually can define your knowledge base. So if you click on this, I just want to make sure that I'm in the right region. US East 1. Okay. So this is where you create your knowledge base. But knowledge base requires uh, a data source. So in this, for the case of this demo, we are actually going to create a data source, which is going to be S3 bucket. So let me just go ahead and actually create a bucket, and I'm going to upload all those text documents, right, which represents my corporate uh, digital data, right, out of which my bot who is going to actually run. Let's name this as campus FAQ um, demo, campus FAQ demo, and I just want to make it unique. So 04 06 2026. So for some of you who don't know S3 bucket previously, have not worked with it, it's basically an object storage service. You can essentially, a bucket is a folder where you can upload your files, could be digital file, media file, audio file, any kind of file, right? Movie files, right? Uh, in this case, we are actually going to upload the text documents I just showed you. So hopefully this is unique. I'm going to choose all the defaults, and I'm going to go ahead and actually create a bucket. So great, the bucket has been created. Now let's actually go ahead and upload all my knowledge base, right? So let's go ahead and actually add files. Yeah. You can see that my local knowledge base, I'm going to actually add to the knowledge base. So I'm going to add it to the S3 bucket. Let me select all of these. Um, Open, and I'm going to leave all the other defaults, and I'm going to click upload. So all of these documents are uploaded to S3 bucket. Now I'm going to define my knowledge base, and I'm going to point my knowledge base to this S3 bucket. Okay. Uh, Also, I'm going to remember the name of this bucket, campus FAQ demo, right? Because we are going to need this later on. All right, so we now have a bucket. We have all these documents. Now I'm going to go ahead and create my knowledge base. So right now I'm in Bedrock under build knowledge bases, and I'm going to go ahead and actually create a knowledge base. So I'm going to actually create a knowledge base with vector store. Okay. Uh, I'm going to name this knowledge base as campus FAQ knowledge base. I'm going to use all the other defaults. But I told you that it once you start creating your knowledge base, you need to provide it with the data source type. Okay, so you have various options in terms of data source that you can actually choose from. So S3 is what I've chosen, but it could be Confluence, it could be web crawler, it could be lot of other things. It could also be custom. Okay, but for the demo sake, I'm just putting like S3 bucket right now. Rest of the things I'm actually going to keep default. I'm going to click next. Um, I'm going to rename um, uh, data source name itself as campus FAQ docs. And this is the place where I actually am going to point my S3 bucket. Okay. So clicking on this, you can actually see that my bucket is actually available over here. So I click on this bucket and choose. I choose this bucket. Now, once you choose your bucket, you also have to define your parsing strategy. So there are multiple parsers, right, that are available that are going to actually uh, parse the content of your bucket. So imagine right now we have only text files, but suppose we want to do advanced extraction like we have PDF, images, audio, video. In that case, I'm going to choose Bedrock data automation as parser. Then you also have foundational models as parsers. So you actually need these models to parse your document. At the end of it, you want to, tokenize these into vector database, right? So this is the parser that I'm choosing, and I'm going to click next. Uh, the embedding model, you have to select what is the embedding model that you are going to use. So for this, I'm going to actually use the Titan embeddings G1, apply. So it is going to use this model to create embeddings out of those text files that I'm going to that I have in the S3 bucket. Okay, and then it asks for vector store. So I'm going to use Amazon S3 vector for now because this is the cheapest. So unless and until you have a very compelling reason, uh, open search and other options are more expensive. So unless and until you have compelling reason, typically go for S3 vectors. Uh, Next, and this is where basically you review and create. So we are going to create this knowledge base, which is actually going to take all those text files and create embeddings in the vector database within S3. So it is still creating a knowledge base. So let's give it a minute or two so it can create it. So you can see that the knowledge base has been created. It has a single data source that we defined. This source is actually pointing to our S3 bucket that contains our files out of which we want to create the knowledge base. Once this knowledge base is created, what we need to do is actually we need to sync. This process is actually going to create the embeddings now. Okay. Uh, and basically populating your vector database at this point in time. So it takes all your text, all your files as input, and it basically stores all the creates the embeddings and stores it into the vector database, right? So let's give it a minute. Let it sync. So sync complete. What we can do is we can actually click on the data source name itself. Um, and you can see over here that all the documents that we have uploaded in the S3 bucket has now been ingested and it is indexed and available for a response. Okay. All right. So one thing that we need now, now we go back to our agent. Our agent is going to utilize this knowledge base that we have just built and is going it is going to respond to us uh, and respond using the knowledge from this knowledge base. It is going to respond to some specific questions that I actually asked out of this agent. Okay. Uh, for that, we actually need the knowledge base ID. So let me just copy that knowledge base ID. Let's copy this. And now we are to the agent. So let me just clean this thing up. Um, all right. So now we have knowledge base query over here. So let's put in the knowledge base that we just used. And remember the iteration that we are doing. So in this iteration, uh, what we are going to do is we are actually going to include the knowledge base. So over here, we are this time we are passing Bedrock agent runtime. Um, and instead of converse, we are actually using retrieve and generate API. Okay. So what it does is, right, it can work in two modes, right? So what it can do is it can you can basically do a prompt and it can basically pick up the relevant sections of the documents that are relevant to your search and it can just retrieve those, or in retrieve and generate mode it is actually going to retrieve the information from the knowledge base and then it is going to use that information plus the user prompt to generate a response. Okay. So the input essentially is the question. Question type is knowledge base. And basically, we are passing the knowledge base ID and the model ID. We are capturing the output, but we are also capturing the citations. Citations are the chunk of documents that have the relevant information that this model used to generate the response. Okay, uh, and then we basically print it out. So my question is, when is the spring break this year, right? So the spring break this year. Look at these documents, right? And we need to find a document which will have relevant information. Most probably academic calendar might have the break information. I don't know. But actually, let's go ahead and execute this knowledge base query. We need to obviously save it. We had updated the knowledge base over here. Just let me just make sure that knowledge base is correct. 5REZ, 5REX, 5REX. Okay. Control S. Let's go ahead and actually execute this agent. Okay. Um, Python uh, knowledge base query. Okay. So this is basically querying the Bedrock knowledge base. Question is, when is spring break this year? The answer is spring break for 2026-27 academic year is March 8th to March 12, 2027. Okay. And the source that it is quoting is uh, academic calendar, right? So I think it has found some relevant text information from here. Okay. Um, all right. So now it can answer all these relevant questions. Let me just change the prompt over here. Are there any other questions that we could actually answer. Uh, I have another prompt over here. That is, tell me about financial aids. Most probably it is going to come from financial aid. Let's control S. Um, uh, Clear. I've changed the question. I'm just prompting it with some another question over here. So the question was, tell me about financial aids. The answer is financial aid at Greenfield University includes federal grants, blah blah blah, merit scholarship and things like that. And it has sourced it from financial aid, right? So now you can see that we now have a agent that can basically answer questions based on the knowledge base that you already have, right? Imagine the amount of knowledge base that you have within your own respective organizations. So HR has all these documents, but they get pinged by all of us at different times, asking different queries. But think of setting up something like this that can answer some of the questions that you are most always prompted for, right? And just making it available for general public within your company. All right. So this is about knowledge base. Now, one thing I want to see over here is, um, let me just do one thing. Uh, so right now I've been executing all the positive cases. Uh, I just want to see, um, oops, uh, who is president of United States? I just want to see if it answers this question. Now, this is a negative case where I don't want my agent. See, my agent is eventually powered by a large language model. So it can definitely answer a lot of questions, right? But this is a campus FAQ agent, right? I don't want it to be, responding to things that it actually should not. I'm coming to some of the controls that we can do actually put in place. Uh, Let me just see if it answers that question, though, right? The model cannot find sufficient information to answer the question, right? So this is an active guardrail that is actually in use over here. So essentially, you have an agent which has a brain of an LLM, but you want to put certain boundary conditions before you prompt and from the response, so that you have tight control over the input and output, right? You do not want it to be sending some offending messages or hallucinating, making incorrect decisions and things like that, right? For that, you put what we call as guardrails. So guardrails basically are overall control that you put in place for your LLMs to basically, these are the boundary conditions within which they actually need to work. Okay. Uh, to create a guardrail, so that's the next agent, that's the next level of evolution. We are putting some sort of control over this agent so that it doesn't answer a lot of different questions. All right. So the next agent is basically guardrails. Okay. How do you actually define guardrails? So just give me a minute. Um, so guardrails basically, are provide, filters. You have content filters, you have denied topics, right? So content filter basically detects harmful content or prompt injection and things like that. You can have topics that can actually be denied, uh, block entire topics. You don't want to engage LLM for certain amount of topics. You can actually block those. You can have word filters, block offending phrases, uh, online bullying and things like that. You can filter for sensitive information. You can detect and block personally identified information, right? You can also do contextual grounding checks, basically reduce hallucinations in RAG, right? So all these things basically get enabled by your guardrails. Okay. Now, how do you actually define guardrails? So let's go back to the um, go back to the management console. So under Bedrock, you have under build. So under build, we had knowledge bases where we actually build the knowledge base, right? The one that we just used. We also can define guardrails. So let's go ahead and actually click on guardrail. And I already have a guardrail. In fact, let me just get rid of this because I want to demonstrate the process of creating it. So let's actually go ahead and create a guardrail, okay? So you can actually create a guardrail. You have to provide a name. Rest others, I think I'm just going to go for it. So you can basically do filters based on harmful category. You can actually do this. You can filter for hate, sons, all these things. You can do prompt attacks. You can enable these. And actually, so this is basically the content filter part of it. You can do next. You can add denied topics over here. I'm not going to actually do it. So let's click on next. Uh, you can add, profanity filter. You can add, uh, sensitive information filter. You can add regex patterns for that. I'm actually going to skip all of that for interest of time. You can do grounding, right? You can actually add automated reasoning test and checks. Next, let's actually go ahead and create this guardrail. Okay. Um, and once you go ahead and create the guardrail, so once you have the guardrail, remember that this is still not in production. Okay, I mean no one can actually use it. What you have over here is you can actually do, you can use this guardrail and you can actually use this prompt to actually test and fine tune your guardrails, and you will actually do this multiple times before you actually put your guardrails into production, right? Uh, I mean guardrails could be too tight or too open, right? But that fine tuning actually has to come at the end of it, and that will require few iterations. But once you have the final piece and fine tuning in place, what you're actually going to do is uh, you can actually create a version of it, right? So once I create a version, we have version one over here. So now I can actually just copy this guardrail ID and move to an agent with a knowledge base with guardrail in place. Okay, so let's actually go to this guardrails one. So over here, I mean this is again the fourth iteration of the agent that we have built. Same logic. Now, but now we have to put the knowledge base guardrail ID. So let me put the guardrail ID. I'm also going to put the knowledge base ID from here, the one that we previously used. All right. REST version 1, of course, model this. Now, again, we are going to do the same kind of call, but now you can see that as part of the API call, we are also passing this generation configuration here, okay, where we are passing the guardrail ID and the version, right? So this is the only difference from the previous version. But now, if I look at the prompts over here, I have deliberately put, a question: how can I cheat on my finals this year, right? If basically this is something that actually our LLM should not, our agent should not engage with this response, right? It should not help the students do cheating. So let's actually go ahead and see, and if it works, you should get a standard response based on the guardrail. Um, Clear. Um, let's maximize the screen. Uh, Python. Um, Guard fails. Let's see what do we get. You can see that basically you have a question: how can I cheat on my finals this year? The answer is sorry, the model cannot answer this question. This is a message that I think you should be able to customize from your guardrail. Um, I think when we created this guardrail, there was setting where we could actually change that message. Edit, uh, or I think I'll just give it a pass for now. So this is how actually guardrail works. Let's take a positive use case. Um, the positive use case is it should be able to answer my genuine questions, like when is the spring break this year, right? So let's actually execute this again with the changed prompt. So you see how it is doing. It is planning. I will look for the information about the spring break dates in the provided search results. Step one: review the search results to find information about spring break dates. Identify relevant information about this, provide answer based on this, right? So relevant information, it has found in academic calendar, and basically it is responding spring break for 2026-27 academic year is March 8th through March 12th, 27. The from the knowledge base that you have actually built. Okay. So this is basically with the guardrail. Now I have shown this painful way of building the agentic AI solution step by step through Python, just to make sure that we become very comfortable with all these concepts that we have discussed. I mean, we have talked about Bedrock, we have talked about Agent Core, we have talked about a knowledge base, uh, inference, tokenization, a vector database, all these things, right? And we have built it over a period of time. We have discussed about toolings as well, right? But in real world, what you don't, you can actually do it. I mean, you can build it using Python and stuff, right? But in real world production environment, when we are building production ready agents, we actually typically use, you know, uh, agentic frameworks. Like in this case, we are using strands, uh, and this basically simplifies a lot of low tunneling code that we have actually done piece by piece. So in actual real world, the code really doesn't look that difficult. So this is a strands agent. This is the full end-to-end uh, featured agent as a campus bot that actually works based on the knowledge base that we have created in an interactive manner. Okay. So essentially, this is not like a single shot prompt. So if I just put all these values, but before we do that, essentially, let's quickly take a look at. the code itself. Control J. All right. So as part of this, we have actually imported strands. We have imported uh, Bedrock from strands models and strand tools. Again, these are packages that I have actually already installed on my system, right? So I'm just going to put this information out in the chat in case if I just don't want to miss it. Um, Let me just put this information out. All right. Uh, so I've already installed Boto 3 as part of my first agent. But as for running Strands agent, I've also installed Strands agent and Strands agents tools. It provides, the required packages for us to be able to define tools. So you define tool through annotations. We have a tool called lookup course. Okay. In this, basically, it I have kind of hard coded all these courses over here, but it could actually come from some course API. Um, you have the keys, and basically you return this, and then you have basically you create university agent. In this, we are just passing model ID, region, temperature, max token, guardrail ID. See all of this as simple as this, right? Once we have this, we have the same system prompt, and we define our agent, right? And then we basically return our agent. In the main, we are basically just creating our university agent. What it does is this agent actually just keeps going in a loop, looking for your prompts, okay, and answering questions as they come. And you can also say goodbye, and it is going to break. Otherwise, it is going to keep answering your questions. Okay. Now we are going to summarize this pretty quickly. Let's go ahead and actually run this. Uh, Before that, let's paste knowledge base ID. Uh, right. Uh, Guardrail ID. Just make sure it is the same. Like two. Is all fine. Everything else is in place. Control S. Control P. All right. Control J. So we are on to the last agent now. Here we are essentially executing. Nope. Something is not right. Clear. Uh, Python. Uh, Trans agent. All right, let's see. Uh, so essentially, it says it's a university chatbot. Ask me information about financial aid, housing, dining, course schedules. Tell me about courses. Let's see. So it is thinking, um, giving a lot of information over here, registration and things like that. Um, you give me fee structure. User is asking for fee structure. I should retrieve information about that. It doesn't have fee structure. I cannot do this. Um, it did have the information about the fee structure though, right? So I'm not sure what has happened here. Um, Let me ask the exact question. By the way, what was my prompt in the knowledge base? When is the spring break this year? Let's ask this question exactly. Um Thinking retrieval does not contain information about spring break. I should inform, so something is not right. Uh, Guardrail version. I hope it's the same knowledge base though. Hmm. All right, so maybe I've hit some sort of token limits. Uh, Obviously, my this thing is not finding the answer for fee structure. Okay, so I might have hit some issue over here. Maybe it's the token limits or something to do with that though. Okay. But essentially, I mean, the essential principle is the same. This is how the agents actually work. They can work with the tool, they can work with databases, they can work with APIs, they can get the action done. That kind of concludes this workshop and this presentation on generative AI. Let me know if there are any questions from my side, from your side. I'm willing to have happily answer. How can I call an agent defined in Azure from my agent in AWS? So this is an interesting proposition. So you are basically saying multi-cloud agentic infrastructure where basically different agents are calling. I have not explored this unfortunately. Um, so basically, agent defined in Azure talking to an agent in AWS. Maybe API gateway, some sort of integration. I'm not saying it's impossible. It's not impossible. I mean, definitely possible through some sort of integration, but something that I'm not very well aware of. Any more questions? All right, great. Thank you for your participation. I mean, I hope the session helps you, get ready and start building your agentic AIs and not just using the AI agents. So, thank you very much for your participation and time.
Hi, please stay back, everyone. Just a request. Um, we have. Hmm, I'm taking over the controls and sharing the screen. If yeah, any question or answers? Though we are running out of time, so if there are any questions, please email it to me and send them to Naveen. And we will get back to you. In the meanwhile, as we come to the end of today's AWS Discovery Day, I would like to thank each one of you for joining us and being a part of the session. Today, we explored how AI is evolving from traditional LLMs to autonomous AI agents and why agentic AI is becoming one of the most important technology shifts organizations need to understand. A special thank you to our speaker, Naveen Shahi, for sharing his expertise, practical insights, and the real world perspective on future AI systems.
Thanks, Ashutosh.
A- At
Thank you,
EdForce,
everyone.
at EdForce, our mission is to help technology professionals and organizations stay ahead of emerging technologies through expert-led learning experiences, AWS Discovery Days, certifications, and workforce upscaling initiatives. Before you leave, we have one exciting opportunity to share. We are currently developing AWS and Agentic AI success case studies based on insights, learning outcomes, and real world adoption journey from participants attending the AWS Discovery Day. Just as